Next on our requirements engineering journey is the documentation phase. So you elicited requirements, you resolved all conflicting requirements or contradicting requirements, and now we're going to have a closer look at properly documenting all the requirements. First, we'll have a look at documentation in general. Why is it important? What's the purpose? Then we have a look at criteria for good requirements. And then we're gonna focus first on the structure, the proper structuring of documents for requirements documentation purposes. And we're also gonna have a look at some templates that exist from various types of organizations that could maybe help you in the future for your job as a requirements engineer. First, we're going to talk about documentation in general. So software projects usually, if you have a certain size that goes beyond just like a static website, require a lot of cooperation of a large number of people, stakeholders. So if it's the software for a new car or an operation system or a tax return system or something else, usually like you have more than 5 people involved in this. And it also may extend over a significant period of times, are usually contract-based, and they may also require maintenance over many years. And throughout this time, there's a lot of fluctuation in the people involved in this. At some point, like maybe no one from the original team is present anymore. So you really have to think about how do you make sure that the information that have been collected in the beginning, then it's later changed, and like all the knowledge that you have gathered throughout this project time is somehow accessible to all the relevant people. And documentation thereby serves a really important task here, or it's a really important purpose. Because if you do not properly document all the knowledge and all the information that you gathered from day one till the present day, and also for the future of the next generation of involved stakeholders, then you might run into a lot of very unnecessary problems. Some of them might just be inconvenience, like, hey, now we have to like re-elicit this requirement again. Others might really cause actual deficits to what you're trying to build, or even make the project fail. If you think back to the table or the list of reasons why projects failed, there was a lot about requirements engineering done wrong. So documentation is one of the main things that can help you make sure that things don't go wrong. There is a tendency, I'm not trying to be so negative about agile methods in general, but there is a tendency in agile methods which tries to avoid documentation or in-depth or proper documentation. And this leads to short-term gains because you have more time doing the actual work, but incurs long-term costs. Someone has to like make up for this missing documentation at some point. That's why we are like putting a really like huge emphasis on documentation is important. Yes, I know it's not the most fun thing to do, but someone has to pay for this later on. And it could be you who has to figure out what other people did not properly do and document in the past. So it's not just like you trying to push away work. Others might have done this in the past and now you have to suffer. So consider that before neglecting the documentation phase. So why do we want to document requirements in the first place, besides those general things that we just talked about? First, because the requirements are the basis of the system development. They influence the analysis, design, implementation, and the test phase. And if the requirements are not properly documented, it has obviously a very strong impact on your project. There's another reason, which is related to the specification that could have legal relevance. So for example, in a medical context or legal context, there is like some things need to be documented so that legal people can check it. So it's often this foundation for contracts in the sense of what needs to be done and what needs to be fulfilled, but also just in the contract that you as a company who is doing a software development project for a customer might have. Because how do you like prove that you've delivered everything that was required? You could do so by having a complete catalog of requirements and then a project done, or like a product where you can see or like make a mapping from each and every requirement to the final product, and thereby stating, look, I'm done, I'm ready, like please pay me. So from this perspective, it can also have legal relevance. Requirements are also possibly extremely complex, and the more complex something is, the more difficult it is to just keep it in your head or like on like some weird pieces of paper. If you have thousands of requirements, hundreds of stakeholders, you have to adhere to certain ISO norms, standardizations, and whatever, then it's so complex you need to write something down. And since it's also so much, you need to structure it properly. And last but not least, requirements also must be accessible. Without documentation access for all the involved persons, that is not possible. If it's just in the head of a single person, you cannot properly implement the system. And we previously talked about communication in the initial lectures, and documentation is obviously a way to communicate information. First of all, within your team, but also over time, as we just discussed in the previous slides. And also between developers and the customers, for example, via a contractual framework. And what type of communication purpose it serves also depends on the dimensions that you are considering here. For example, the involved stakeholder groups and their capability to deal with certain notations. A marketing person might not be really familiar with the UML diagrams. Or it could also depend on the project characteristics like reliability or the maintenance period. And finally, also the amount, form, and contents of the requirements documentation that is needed to be adapted. So all of this is something you have to keep in mind when working on your documentation. Before we move on to the more details, we would like to have a look at documentations versus specification, because there's those are important terms in requirement engineering and software development. So documentation refers to any form of information written down relating to software or system architects. Requirements documentation, thereby, is any form of explicit documentation of a requirement. So documentation, requirements documentation, even more explicit. Requirement is any documented information relating to a system that shall be developed. And please note that it's sometimes used in contrast to specification, that requirements are only like informal requirements, but that does not necessarily need to be the case. Something that might also help you to visualize the difference a little bit more is that documentation, the yellow outer box, requirements in the middle, and then specification being requirements documentation that is in accordance with a certain specification approach. Does not necessarily have to be formal, but it's often the case. And this is sometimes used to imply that requirements are specified on the level of developer requirements. We will not use it this way. So just to differentiate those different parts a little bit, so documentation, requirements, and specification. We also already talked about the different types of requirements, and we already highlighted that for the functional requirements, you tend to look at those from different perspectives that then help you to document the functional requirements in a better way. And now we're coming back to something that we have seen previously. So we talked about the different types of requirements, and that, for example, functional requirements are often documented using three perspectives: the data perspective, the functional perspective, and the behavioral perspective. So looking at a problem, at a requirement as something that you want from a system from different perspectives can help you to better document it. So the three different perspectives that you already are familiar with, but not how they really help you with respect to the documentation tasks. So the data perspective is often used to get a better understanding of the static structural aspects of your system. So what is the structure of input and output data? Is it an XML file? And if yes, what are the XML tags? Is it JSON? Is it a PNG file? What is it? How is the data structured? The static structure of the system itself is something that is relevant to you. What are the usage relationship? What are dependencies? So this is what you are trying to gain when you're documenting it using or from the perspective of the data aspects. The functional perspective is concerned with information received by the system and how it's manipulated. So essentially the data flow through the system. While the data perspective was static, this is way more dynamic. So you're trying to essentially figure out what's happening there with data throughout this whole system. And then finally, the behavioral perspective, which is a state-oriented perspective on how the system is embedded into the system context. So documents reactions by the system on events in the system context. So trigger, output, or trigger and what happens then. The reactions depends on the system state, like which state is the system right now when a certain trigger is hit and what happens then. And the reactions include state transitions and effects on the system's environment. So from your bachelor's degree, you probably are familiar or like remember those state machines where you have a state, it moves into a different state, which was caused by a trigger that then activated the transitions. Pretty much the same background or understanding here. And besides the three different perspectives, we are now looking at three different ways to document requirements. So they are not related, it's just by accident that it's always three. And we will mostly focus on those three major categories for the rest of this lecture. So first, we're going to look at natural languages to document information and requirements, then conceptual models, and then some hybrid approaches. As usual, there is no best solution. You need all of them. It depends on what type of project you have, how big is your project, who's part of your team. So many different factors, and some techniques are good at this, others are good at that. Long story short, this is why we teach you different approaches so that when you are in the situation, you can select the best suitable option for your needs in this specific project and situation, and then make the best of this. It's not going to be a complete list. It's just like a good selection that we think might help you and make your life as a requirements engineer easier. So first, natural language is the most commonly applied form of documentation. You write what you speak or what you think or what you communicate. And the advantage is that it can be read by every stakeholder, assuming that you're speaking the same language. It's applicable for miscellaneous purposes. It can be used for any kind of requirement. It's very well suited for all the three perspectives that we just talked about, but it also has some drawbacks. There is a huge potential for ambiguities, which we're going to cover in a little more detail later. And there's also the risk of having an unintentional mix of different kinds of requirements and perspectives. So you have to be aware of that. Besides the natural language way of documenting models, we're also going to look heavily into the conceptual models. So you might have very different conceptual models and approaches and modeling techniques there. None of them is universal, and you have to pick them depending on the perspective or the type of requirement that you want to elicit. Among the advantages is that if you use them correctly, you don't have switches of perspective, or you don't need a switch of perspective. They have a very compact documentation. You can put a lot of information that are very complex and difficult to understand in a very good conceptual model. So a lot of things that you would need to write down in hundreds of pages can be fit into a nice, good conceptual model. It's also very easy to read for a trained person who is familiar with this conceptual modeling technique, and it's also less ambiguous than natural language. Drawback, you need to know and understand this modeling. You need to know UML, or you need to understand it, and you need to use it correctly. So use case diagrams are probably very familiar to most of you. They give you a quick overview of the system functionalities, but they do not describe responsibilities in detail. But you can already put quite a lot in there that would take you quite a while to describe in natural language, and also like for the reader to understand what was written there. Well, it's super easy for me to just look at it and understand, okay, good, got it. Class diagrams, very good for the data perspective. They give you the static structure of data, the structural dependencies between the system and the context, so very nice. Once again, you need to understand how it works to utilize it to the fullest. Activity diagrams might also be quite interesting. We'll get back to those later. State diagrams, we talked about the state machine aspects. But no single type of documentation fits everything. It depends on your view, your audience, what you need to capture, and so on and so on. And what will finally happen in your requirements document is that you usually have some kind of a hybrid approach where you mix natural language with conceptual models. Try to be not redundant, but rather use them complementary. Use the conceptual models for things where conceptual models are required and good. Supplement it with natural language where this is applicable. So balance out each other's weaknesses. Example, description of the general architecture in a natural language, and then the details in form of models, which is where models are really good at.